Muted.
Hello, everybody. Welcome to today's webinar, The Dynamics of Sealing. I am Amanda Harmoning. I am an admin assistant here at AERA, and we'll be moderating today's event. And joining me to help answer questions is Rob Monroe.
Hello, everyone. Rob Monroe here. Yeah, both Amanda and I, we're going to be in the background to help answer any questions that you got throughout the webinar. I look after membership and technical development here at AERA. If you do have any questions, Amanda's going to show you here in the next few slides how to use your control panel. And we'll leave some time at the end for Brian to be able to answer those questions for you. If you have anything membership related or anything you want to chat about through the presentation, just go ahead and put it in that questions box, and Brian will we'll get to those at the end or throughout the webinar. So I'll go back to Amanda, and she'll show you how to use that control panel.
All right. So there's a couple different ways to listen into today's webinar. One is to dial in via phone. If you do this, make sure you have that telephone radio button selected and you enter your access code and audio pin. This just helps make sure that everyone's lines are muted and there's no disruptions or background noise during the presentation. The other way is to listen in with your computer's mic and speakers, and again, just make sure that appropriate button is selected so we don't have to worry about any interference in the background. A couple other quick things to know. There is that little orangish box with the arrow in it. That is your grab tab. This allows you to collapse and expand your control panel so that it's out of the way during the presentation. You can maximize your viewing screen. The last thing is the questions box. At the bottom of your control panel, you should have a questions box. And if at any time you have any questions or comments for us, go ahead and enter those in there, and Rob and I will be in the background answering what we can, and then at the end we will do the live Q&A with Brian. So at this time, I'm going to switch things back over to Rob, and we'll get rolling with today's presentation.
Super, thanks, Amanda. Just a few housekeeping slides here before we get started with Brian's presentation. We just finished up one of our regional conferences out at Motor State Distributing out in Michigan, and something that we're doing lots of this year is we have lots of tech and skills conferences throughout the country. And we do this so that we give you the ability to be able to get together, network as a group. We have technical presentations that we put on at the host facilities for you to learn from. There's lunch put on by the hosts and that sort of thing. But right back here, I mean, even looking back at by 1926, if we look at this particular picture in this newsletter that we had way back when, I mean, these are folks that were engine builders just like most of you, and they all got together to network as well. And this is how we learn from each other. The idea is that maybe Monday morning you can bring back some of the ideas and things that you've learned and apply it right to your business or shop. And then that's why we're doing this kind of thing throughout the year. So we have 5 more. We've got Sun and Products. That's going to be May 3rd out in Missouri. And you'll even see on your control panel, Amanda has placed in the handouts section, there's a little section there in your control panel that says handouts, and you can click that. And there's a PDF of the Sun and Products Regional right in there for you to download to have a look at. So it is there if you want more information. We're going to be at Bakersfield College May 18th out in California. TriStar Engines August 9th will be in Wisconsin. Liberty Engine Parts will be September 14th and we'll be out in Pennsylvania. And then to wind things up for the year for 2019 will be Rottler Manufacturing, and that'll be October 10th and 11th out in Washington. So again, we encourage you to, if you're within driving distance of any of these, you can reach out and get out to some of these. It's a great event. If you are a member of AERA, through our Engine Rebuilders Educational Foundation, we will reimburse you $50 per shop if you do attend these particular regionals. So that'll help pay for some gas money and get you out there. So again, if you have any questions on those, you can throw the presentation. We'll answer those as we go along. But we look forward to seeing a lot of you at some of these events here throughout the year. Another thing that we've got, for those of you that are members, I mean, we just want to keep in mind that there are 4 of us that are on the tech line. We're Monday through Friday, 7 a.m. right through till 6 p.m. Central. And Brian Roberts, our presenter today, he is on the phone and he is working the tech all day long. So if you do have any questions, you can get a hold of us. What I do encourage is to take advantage of that as a member. If you've maybe got a list of engines that you're working on for the week and you need that information, you can go ahead and email us. You can go ahead and phone us. Maybe you've got a business-related question in regards to your shop or business. Anything like that we can help you with. Process Pro. Even we can spend some time with you if you want to learn how to get a little bit faster and get a bit better with the Process Pro software. Just go ahead and get a hold of us and we'll spend some time with you and we'll have you, you'll be a pro at it before long. So for now, let's get on with Brian's presentation. He's got a good one coming up for this time. Today's presenter, I mean, he is one of our techs here at AERA, and Brian Roberts has over 20 years of experience in automotive aftermarket. He worked with Silicon Technologies as well as Federal Mogul and with Felpro. He worked at Dana Corporation where he was product engineer and product manager before coming over to AERA. So Brian, how's it going today?
Going good, thanks, Rob. All right, can everybody see the screen? See it?
Yeah, we can. Okay. Yeah, you can. If you can, if you got a presentation mode there, it might just pop it just a little bit bigger.
Let's see. How do I do that here?
Right down at the bottom there where it says notes, if you go over to next to the little the book, yeah, keep going right there. A little bit further. Next one over, and that right next to the volume control or the screen control, you see sort of take your mouse to the left just a little bit, and click that right there. Yep, that should make it bigger for you.
Is that doing anything on? It's showing full screen on my screen right now.
Okay.
Is it showing all the different slides to the left?
Yeah, yeah, it's still showing. It is on our end still.
Okay, let's apologize, folks. What can I do here? Get this to full screen. Well,
Brian, go to slideshow.
okay.
The tab at the top.
Mm-hmm.
And then keep going over. It says from beginning and click on that.
That's what I have. And it's full screen on the right screen that I'm looking at. All right.
Well, that's all right, Brian. We've got, I mean, if you want to go ahead and start the slideshow like that, it's
I guess we have no choice.
I don't know. Yeah, no, it's something glitch in there. So yeah, go ahead, go for it.
Okay, so I guess I'll just click on that guy. All right. So apologize again for the technical glitch here. So we're going to talk about dynamic seals. So what is a dynamic seal? It's basically a seal that is stationary while other components around it are in motion. So that motion, creates unique challenges with, friction and heat that's not seen on like a stationary gasket, like a head gasket. Even though the head is moving, it's not moving like a rotating shaft or a valve traveling through a valve stem seal. So that friction and movement creates heat, and that heat and friction creates wear. So dynamic seals will require some kind of lubrication to combat that. So common dynamic seals that we're going to talk about are valve stem seals and oil seals. So what's the function of a valve stem seal? Well, basically it's just metering the oil into the valve guide. So it's not a total seal. You're going to need that lubrication inside the guide to combat the friction and heat that's moving as the valve travels up and down in the guide. So, and then sometimes the valve stem seal will serve as a spring seat. In later designs, you'll see that. So here's a typical valve stem seal cross sections. Kind of moves across the history of the valve stem seal. You've got the umbrella, you've got like a multi-lip design, and you got the single lip. It's basically the most common application in valve stem seal today. And then you have the top hat design, and you have what you can see here is that spring seat down here. The umbrella, this we'll get to, was very early on, and engines used the umbrella seals. The actual seal was pressed onto the stem of the valve, and for anybody that's done like the old plastic kind of Bakelite type ones, you understand how difficult it is to install those, to get them over it. But basically it's riding with the valve, so it's in motion with the valve, and all it's really doing is, you know, trying to reduce the amount of splash oil that's entering the guide. If you get too much, you know, oil going into the guide, now you're going to have excess oil consumption and combustion, and you'll end up having like a bluish smoke coming out the tailpipe. Later generations moved on to what they call positive seals. So they're positive because they kind of positively stay locked onto the valve guide. So as you can see here, this multi-lip design guide, it slides over the guide and kind of locks onto it with a cinch band, which is kind of hard to see here. Then over here, you've got the positive style that's more common today. It slides over the guide, locks onto it with this rubber inside the idea of that shell. So it's like an interference fit onto it. So the valve stem seals come in like a single lip design with the metal shell, multi-lip with the coil bands that we just discussed, and they are offered in various different compounds depending on the operating environment. And those compounds have changed in their usage over the years, and we'll cover that down the road here. Here we have the top hat design, which is more common today with aluminum engines. So it's basically the same as the early positive seal with the single lip, except for it has this integral spring seat built into it. And that serves as a basically spring seat for the valve spring itself. So without that shim there on aluminum heads, as that valve is going up and down, the spring is compressing and not compressing. If that shim wasn't there, you'd be eating into the aluminum head over time. Valve stem seal installation. Okay, so on the valve stem seals, you press the valve stem seal here over the stem of the valve, but you have these keeper grooves in there, and sometimes those keeper grooves can have sharp edges on them. So you have a potential as you're pressing the seal over it to damage the lip. If you damage the lip, now you have a larger leak path, because again, we're not totally sealing, we're just metering the oil. So you'll have a larger leak path, more oil will enter the guide, and you'll start consuming oil in combustion. So many aftermarket suppliers have this plastic type sleeve that's available in a variety of different sizes depending on the valve stem diameter. You slide that guy over, it protects the lip of the seal from the keepers, the keeper groove if it's sharp. So it slides over, gets past the keeper groove, and you're good to go. So boom, boom, boom. The rubber compounds that are used in valve stem seals and or oil seals today, these are the common ones. Nitrile, also known as MBR, silicone. These abbreviations are just the industry abbreviations for it, or commonly known abbreviations. Polyacrylate, fluoroelastomers, also known as Viton or FKM, and the latest generation of at least oil seals, and some valve stem seals have a PTFE lip. And here's why you'll see the progression of the rubber compounds. So here's just like a generalization of material properties. You know, depending on the formulation of the compound, it can vary, but this is just a generalization. So if you look at nitrile, it has an operating temperature range of -65 to 230 on the Fahrenheit. Polyacrylate -30 to 340. Silicone has a very wide range, -175 to +375. FKM -25 to 450. Teflon -15 to 400. So you look at that and go, well, silicone has this great temperature range. Why don't we use that all the time? Well, you look at the abrasive resistance on there. It's only fair. Its set resistance, it's very good. If you don't know what set resistance is, it's like compression set. So as the rubber heat ages over time, it takes a set. So different compounds respond better than others in set resistance. So, but the key there is the tensile strength. On silicone, it's got poor tensile strength, so it could easily be torn. So if you have any kind of imperfection on the shaft that could grab it, it could tear it. So any kind of dirt, debris that could hit that lip has more likelihood of being torn. So if you look at the chemical resistance, the engine oils, diesel oils, you know, silicone's good in, you know, regular traditional aftermarket automotive engine oils, but not in diesel oil. It's good against ozone. So the ozone gases can affect rubber compounds and cause them to crack. So you got to look at that as well. So when you look at that chart, you can see that FKM is basically the go-to standard in today's engines for extended warranties. As you can see, it has excellent properties in almost everything except for tensile strength. So, and even there, it's very good. And so most manufacturers now are going to be using an FKM oil seal or valve stem seal, again, to get through extended warranty programs. You look to the far right, that Teflon, that's the latest technology out there. Again, excellent properties across the board. Really don't have to worry about set resistance because it's not an elastomer, and tensile strength is not a real issue on it. So again, just taking a look at this chart so you can understand the rubber compounds and why they're used. And doesn't mean that nitrile, polyacrylate, silicone are not used. They're just not used as commonly anymore. And how does those valve stem seals get validated? Well, aftermarket suppliers utilize these dynamic test rigs to validate the seal. So they simulate, you know, engine RPM range, operating temperatures, vacuum seen on the vehicles. You know, each manufacturer has their own testing, you know, procedure, and basically all it is doing is it's simulating an engine and it's collecting in a cup the oil that's getting past the seal. So they can benchmark it against an OE seal or whatever seal that they feel is the one they want to use as the benchmark. And then after they're done with the testing, they compare that, and if it's favorable, they can release it. Yeah, that's basically all I can tell you about kind of a non-disclosure agreement. I can't really talk much more about that. So, but that's basically how the aftermarket players do their validation to make sure that they're giving you a quality product. So, symptoms of worn valve stem seals. Most of you probably know you're going to see smoke coming out of the tailpipe at the cold startup. You know, so as that valve stem seal is degraded over time, more oil enters combustion. As the engine sits, it just drips down into there, forms into the combustion area. You start up the engine, boom, you get a big puff of smoke, and that burns like that for a little bit until the excess oil is gone, and then it's okay. So that excess oiling could also foul the spark plugs. So you might have really oily spark plugs that the oily spark plug could produce a misfire situation. You know, some guys try and combat that with a higher heat range spark plug, which can kind of overcome some of that fouling, but it could also lead to pre-ignition because now you're having a hotter spark that, you know, that air fuel mixture comes into contact with, and it could cause a pre-ignition. So things to be aware of. So that'll bring you into oil seals. So oil seals basically are located in the front and rear of the engine for the crankshaft. Maybe on an overhead cam situation, they're in that place as well. So the seals need to allow the crankshaft or whatever the shaft, the rotating shaft, to spin, which will create friction and heat, but it needs to maintain a contact with that so it will contain the oil, and then the oil that's on the shaft is also lubricating the lip of the seal to protect it from being destroyed. So, the early seals like that were rope seals, so comprised of fibers to combat friction and heat while absorbing the oil and preventing it from escaping. So if anybody's out there working with today's rope seals, they'll probably understand how difficult it is to cut those new rope seals. If you got a new razor blade, it's a challenge. Dull razor blade, you can forget about it. So when you're trying to cut that guy, it's a struggle. So just make sure you have a very sharp razor blade and take your time. It's gonna be a little difficult. So, but anyway, you take that rope and you pack it tightly into the rear cap or the block. And once you get that packed in tightly, then you cut it at the parting line with the new razor blade. Then you take a little bit of oil or some kind of grease and you lubricate that surface, and that's your break-in. So you don't want to install it completely dry. You want to have it break in a little. So should also probably put an anaerobic sealer, at the cap or the block, not both. If you end up putting it in both, then you can have excess material and it's going to try and extrude out, and then you can end up with potential clearance issues with your bearings. So, and then excess clearance, now you have oil pressure issues. So there's a tool like this that you could use to kind of rock back and forth to seat that thing in there, or you can use like a rolling pin and roll it back and forth to get it packed in there, because that packing is critical. The volume inside of these ropes has been calculated so that once it's packed in tightly, it will allow the crankshaft to rotate freely with some resistance to maintain a seal. If that calculation's off, you could not have enough compressibility and volume in there, and the thing will spin real free because there's no resistance on it and there's leak path. Or if it's off the other direction, you could barely turn the crankshaft at all because there's too much material. So the engineers have calculated the exact amount of volume needed to be packed into that to get that to seal correctly. So here's a chart that the AERA's put together of rope seal alternatives. So you got a lot of guys out there that just are frustrated with rope seals. They hate them, difficult to install, don't always work, for specific reasons, So the AERA has got a list of alternative, basically two-piece oil seals, rubber oil seals to replace the rope. Now the aftermarket guys sell these, and here's their part numbers. You can see the chart's old because Detroit's still on there and Roll's on there. Those guys are gone, but they do not endorse and say that these will work. These are their part numbers that members have been successful in utilizing to replace a rope seal. So again, the manufacturers are not saying that these seals of theirs that were designed for something else are going to work in a rope seal application. The members have proven that and been successful. So they utilize these, and as they call in and they go, hey, do you have any other seal that I could use besides a rope seal? We have this Tech Bulletin 1711, and it lists the alternatives that we have found to be successful in use. Some of those crankshafts will have a knurl on them if they had the rope seal. That knurl doesn't need to be removed, but it should be polished. So any kind of sharp areas or imperfections are taken off, because the rubber seal that's going to go onto it is not going to like that. So I recommend you polish that knurl before you do the installation. And it brings us to the two-piece split seals that followed rope seals. So you've got these two pieces that come together on the crankshaft. So you can do the installation with the crank in or without, or with it out. A lot of guys like to just have the crankshaft in to reduce the amount of labor. So what you could do is basically loosen up the main bearing caps, stick the seal into the groove on the block, and then rotate the crankshaft, and it'll help pull it into place. And what you want to do is leave a portion like 1/4 inch or 3/8 sticking out of the parting line. You don't want to put it even with the parting line. This will help with installation, because you don't want the parting line of the seal to be in the parting line of the cap and block. And so a small amount of grease again, or lubricant, should be on the sealing lip to help break it in. You should apply an anaerobic sealer on the cap mating surface adjacent to the seal, and that'll help seal the cap itself. Again, you just want to put a little bit on. Once it gets torqued up, it spreads out almost the entire surface of the cap. So you don't want to overdo it. Again, you don't want to mess with the crankshaft bearing clearances by putting too much in there. So the important thing is how do you know which way the seal is supposed to be installed? Well, the largest raised lip area, or you see this on this particular seal here, this lip here, that needs to point into the direction of the engine. So it should be pointing inward at the engine. You get that piece stuck in there the opposite way, it's not going to work. You just done a bunch of labor for nothing. So I believe a lot of the aftermarket manufacturers have instruction sheets that tell you these things as well. So pay attention to what the manufacturers are saying in those instruction sheets. I know a lot of times you try to hurry up and you throw those to the side and you miss something. So try and pay attention to the work instructions on those. That was followed later by the one-piece rubber oil seal or metal oil seal. So as you can see here on the left, you've got a metal OD. On the right, you got a rubber OD. So this replaced the two-piece oil seal. Requires a round bore machined into the block or bolt-on type housing to accommodate the seal. Simplified installation. It eliminated the need to remove the crankshaft. The seals are retained in the bore by an interference fit, and that amount of interference will depend upon the OD size of the seal. So here's a cross section of the seal that's got a metal shell OD. So here's the metal shell. It's got a double lip here, so you got a single lip, and what we'll discuss later is a dust lip right here. The radial load from this spring keeps that lip in contact with the shaft as it's rotating. So the tension and placement of that spring is critical when the engineers are designing that. You can see on the OD of this seal here that it's got a red color. That is a coating that is put on for what we call micro seal. So any imperfections in the bore, that coating will help fill that void. So, and here is a rubber OD construction. So you have the same kind of metal shell, it's just smaller because it's over molded with rubber. So these type of seals work well in aluminum bores. So, we'll talk about the OD interference fit. So here's just like some standard like general criteria for interference fit. So if you look here on this chart, you'll see up to 2 inches. If you look at a metal OD, nominal press fit in a steel bore is 5 thousandths. In aluminum bore, it's a little bit more, 6 thousandths. And as you go down, larger in OD, that interference increases. Then if you look over at the rubber OD, you look at the same size, 0 to 2. For a rubber OD, it's 8 thousandths versus 5 on a metal OD, 9 thousandths versus 6 on an aluminum. And again, as you go down, you'll see that that interference increases. So when the engineers are designing these seals, they get the size of the bore for the engine or the housing that's going to be put onto the engine, and they determine what press fit is required using criteria similar to this. So this is just a generalization. Each manufacturer may have their own depending on what they're using. But this just gives you an idea of what kind of interference you're looking at. So again, too, if you, let's say you have a seal that feels like it's too loose, this kind of chart can help you go, do I have the right interference on this? You know, is there something going on with that seal? Has it been used before? And now it's got a set to it. You know, you can kind of understand if it has the right interference or not. Maybe you got some cheap offshore seal you got a great deal on. You know, you may not get the deal you think you're getting because the interference isn't right on it. And this thing's going to want to pop out in operation. So the next thing we should talk about is what we call the helix. So on the lip, you might see little serration like marks, like little lines, like you can see in this, you know, drawing here, these lines. We call these helixes. So the oil's riding on the sealing lip to reduce the friction, you know, reduce the heat from the friction. And then that helix, depending on the rotation of the engine, determines what type of helix will help keep the oil in the engine. So any oil, excess oil that's coming out, it hits that helix and kind of gets pushed back into the engine. So as you can see here, you got, you know, counterclockwise rotation, you know, left-hand rotation, kind of standard rotation engine, you know, clockwise rotation, right-hand rotation. So that's reverse rotation, like in marine applications. Then you have this bidirectional rotation. So these type of seals can be installed in either standard rotation or reverse rotation engines and function. The helix in it will function no matter which direction the shaft is rotating. Then we're going to talk about single versus double lip. So you've got a single lip or a double lip design, and what is the benefit of that? Well, as you can see in this cross section here, you've got a single lip oil seal. You got the oil inside the engine. It's being held back by the lip of the seal here, but there's also dirt and debris from the road that can get up and get at that lip because there's nothing to protect it. So that dirt and debris gets to the lip, and that lip will eventually get destroyed by that dirt or debris because it's a foreign object not supposed to be there. And as that thing is rotating, that debris is on the shaft and it hits the lip and it starts to degrade the lip over time. And eventually the lip will fail and you'll get a leak. So later designs came with what we call the dust lip, which you can see over here. So you got oil coming again, being held back by the lip. Now you have this dust lip that doesn't ride exactly on the shaft. It's real close to it. And it protects the primary sealing lip from that dirt and debris. So that dirt and debris can hit that dust lip all day long and slowly degrade it. And that will extend the longevity and the operating life of the seal with that double lip there. From there, the latest generation of seals, at least that I know of, are Teflon lip oil seals. So this is getting away totally from elastomeric or rubber. It's like a Teflon sheet that's clamped inside a steel housing. The housing is there to have the interference for the bore, and then this lip lays down on the shaft. So as you can see here, you can see this lay down, and you got these serrations here when this lays down, and these serrations act like a helix too. But you need to install these seals dry. Cannot stress that enough. we've educated installers to lubricate the seal for break-in to protect the sealing lip, and that education has come back to kind of bite us with these type of seals. So these need to be installed dry. The material that's in this Teflon lip transfers to the shaft during break-in and creates the seal. If you were to put a lubricant of some kind on there thinking you're going to help the lip, you're not. You'll almost instantly fail because the properties won't transfer over to the shaft and it's going to leak. So cannot stress highly enough, install these guys dry. Most of these type of PTFE seals, Teflon seals, have an installation sleeve that comes with them. If you were to try and install these without these sleeves, you could easily damage the lip that's on there. So the sleeve is designed to slide over the crankshaft, and then the sleeve or the seal itself slides off of that tool and onto the crankshaft. And when it does that, the lip is in the correct orientation and position, and no damage is occurring to the actual lip. And then you can drive it home into the bore for its interference fit. So you can see these like right here, this white piece, that's the installation tool. You might see them in different colors and whatever. Just make sure that you utilize that tool. Don't take it off and try and drive the seal in. You'll end up having issues. I'll talk a little bit about surface finish for these type of seals. So obviously surface finish is critical to the longevity of the seal's life. So too rough a finish is going to produce peaks and valleys, and that's kind of a simulation here of peaks and valleys in a blown up version of a shaft that's been machined. So surface finish needs to be, at least for like elastomerics, roughly in that 18 to 17 RA range to provide a good sealing surface that the sealing lip, the elastomeric sealing lip, can accommodate. You get higher than that, those peaks and valleys, those are just generating leak paths for the oil to get through. The PTFE Teflon, this is the RA finish that I've seen. If Rich Larson is on the line, if this is wrong, please correct me. This is what I found, is a 12 RA finish for PTFE Teflon lip oil seal is needed. Let's say you have an issue with your crankshaft and it has a groove in it that is there from the previous oil seal that was there. You'd have to repair that groove, because if you were to try and install that sleeve over that groove, you would have a problem. Remember, sorry, that new oil seal in at that same spot where that groove from the previous lip was riding, you'll have a leak. So the aftermarket came up with this repair sleeve option to combat the grooves, or at least restore a finish that a new seal can be on. So as you can see here, this is one style of sleeve that gets driven on from the top surface here, gets pressed on there. You've got another style here that's got a lip on it. So you got this cup that goes over it, and then it drives down and sets the sleeve into place. So basically it's a new surface for the seal to ride on, and cuts down on some machining work that you might have to do. So here's a cross section of the repair sleeve in its place. So you can see that the seal gets pushed into the bore, and it would normally ride right here on the shaft, and you got a void or a groove there. So the new sleeve gets pushed in, and then it produces a new surface for the seal to ride on. So it's very thin material. It's a stainless type of material. So it's somewhat of a challenge to drive on, but once you get it on, you've got a nice new surface. So As you can see, that little void, that's the groove that was there. And so to combat that, there was also some seals that had an offset lip. So you can see here that here's the original seal with its lip position. And here's the offset lip that you could buy to put back into the same application. And the sealing lip is now moved inboard, whatever amount of distance. So the new seal's lip is not riding on the groove. Now it's pushed inboard instead of outboard because you want to have an undamaged surface. So outboard, you could potentially have imperfections from dirt and debris on the shaft. So you don't want to push the lip that way. You want to go inboard. So again, you can see that here with the offset lip and the original lip positions. There's very few that were done this way. Obviously, this is probably small block Chevrolet, I'm assuming. That was popular, so that option was available. But prior to that, I don't think there's much options beyond that. But it's just pointing out an option that's also out there for guys that don't want to do this repair sleeve. If you have this option, this is another way to go. So, and that is about it. So, is there any questions?
Sounds good, Brian. That was some good information for sure. Mm-hmm. There are some questions that have come in, and one gentleman has asked the rope seal chart that you showed. Mm-hmm. Is that available somewhere, or would he be able to see that online, or maybe get a hold of that somehow?
The rope seal chart is a tech bulletin that we have for our members. It's part of their membership. I'd have to ask and see if we can give that outside of the membership. If you can get that gentleman's information, I'll find out for sure if I can release that information external to the membership, and I'll take it from there.
Sure, we'll have his email address and everything. So we'll make sure to we can probably get him a copy of that to have. Mm-hmm. He's also asked he'd be interested in that interference chart that you have that you showed in one of your slides as well, if possible.
Yeah, that's fine. That's just general information that's published out online right now, but I'd be happy to share that. Yeah.
Okay,
and
super.
And the chart actually goes up higher in OD size. I just didn't put it on there. But yeah, could definitely share that with them.
Okay, so we'll, after the presentation, like I say, we'll get back to everybody. If there's questions that Brian has to get back to you on, we've got your email addresses, and we'll make sure to get you that information. Another question has come in. You were talking about the Teflon seals and about the importance of installing them dry. Mm-hmm. They're asking, does that apply to valve stem seals as well? That as far as installing them dry?
That's a good question. I would say, and I don't know the answer, but I'm guessing that would be yes, but I will find that out. That you would not want, it's the same premise. If the Teflon lip is the primary sealing lip, if you put a lubricant on there, you're defeating the properties of the Teflon lip to transfer to the valve stem itself. So apologize, I don't have the for sure answer on that, but I'll find out and I'll let you know.
Okay. Yep. No, sounds good. Mm-hmm. One more question for you. Can a journal seal be ground and used as a regular standard seal? I'm not sure if I quite understand that question, but
I'm not sure I do either. Can a journal seal be ground? Are you talking about grinding the lip of the seal?
I think maybe they're talking about the seal surface of a journal. Let's say there's probably, I think I can figure out, they're probably talking about like a crankshaft rear journal surface perhaps, and they're wondering if let's say you machine that, can you still use a regular standard seal?
Oh, okay. You're reducing the diameter of the.
That's kind of how I read it. Yeah.
Okay. Yep. If that's the case, yes, you can. I mean, you should only be taking a few thousandths maybe off to repair the surface, I'm assuming. You know, if that's the case, then yeah, it should still work. You know, because there's enough interference built into there that a few thousandths removed shouldn't matter. But if you're talking, you know, serious amount of material, you know, 5 and up, you could probably get into some issues. You know, just I guess it too depends upon the design of the seal, and that would vary. So, but again, if you're just cleaning up the surface, you know, 1/3000ths, you should be okay.
Okay. All right. Another question is there an easy way to determine what material a given seal is made of?
Unfortunately, no, there's not. You can't go by color because that doesn't really mean anything. I mean, FKMs are usually like a brownish red in color, but that doesn't mean that what you're looking at is truly FKM. So the answer to that is no, there's not an easy way to do that. I mean, we would use what they call an FTIR machine, spectral analysis, to determine what the compound is. And it's an expensive piece of equipment. But, you know, there are some people out there that develop charts where you can burn the material, and depending on the color of the burn, you can kind of guesstimate what the material is. I don't recommend doing that. It's not very accurate. And you're burning something that could be harmful to you if you inhale it. So I wouldn't recommend doing that. So again, there's really no easy way to tell what the material is.
All right. Okay. Question is, in regards to a valve stem seal, can you tell if a failure on the seal itself by looking at it?
Difficult, because whatever you're trying to see is probably so small, you're going to need a microscope to even see it. I mean, let's say you pushed it over a sharp keeper groove and it nicked the lip. You got to look very hard to see that. If it had compression set, that's going to be tough because you don't know what it was originally if you didn't document it. And then so say it's got an ID of 200 thousandths and then takes a set after that. It's the diameter now has changed. Unless you know what the original was, you don't know how much compression set has occurred. So just looking at it, unless there's some kind of catastrophic situation, I don't know how you can see it without a microscope. Maybe doing a cross section of it too. So it's I don't think there's an easy way.
Okay. All right. In regards to oil seals, is there a sealer that you'd recommend to be used on the outside diameter of oil seals?
You're talking about like a Loctite type of situation on the outside?
Just should a sealer be used on the OD of oil seals at all? Like, is it a good idea?
Well, I would follow the manufacturer's recommendation, but in general, you shouldn't need a sealer on the outside. I mean, I know some people put like a Loctite on the metal ones on there, but most of the metal ones have the coating on there to help with any kind of micro sealing imperfections there. The rubber ones don't need it. They're going to accommodate any kind of imperfection in the surface. And by adding that, you could potentially cause an issue where it wants to spit the actual seal out of the bore, especially on a rubber OD. So I wouldn't recommend it, but again, I'd follow the manufacturer's recommendations.
All right. Okay. Another question: can you reuse a dynamic seal if they've only been in for a short period of time?
I would say I would not recommend doing that. I mean, what's a short amount of time? That's who determines what short amount of time is? So, and again, most of the stuff is elastomeric, and everything has a heat age to it. So that set that we talk about, compression set, once it starts to see heat and time, it takes a set. So, and that set is something that's not coming back. So I would not recommend doing that. I know that some of these seals are not cheap, but if you, for whatever reason, have to disassemble and reassemble after a short runtime, I would probably put new stuff in just to be safe, because the labor involved to do the repair, you know, if it has to be done again, probably far outweighs the cost of the seals.
All right. Another one for you. Are there certain seals recommended for friction reduction or improved efficiency?
Certain seals. Well, the latest design, Teflon, I mean, that really has improved the friction reduction with that Teflon coating. I would say that's probably, you know, the type of material or design that I would say is greatly improved on friction reduction. But again, there may not be a Teflon lip version for the application you're talking about. I mean, they're primarily designed for the later model stuff. But I'm sure the aftermarket manufacturers have got some potential Teflon lips for some older popular applications.
All right. Okay, we got time, I think, for about one more question here. So back to valve seals again, Brian. Is it safe to install valve stem seals without that plastic sleeve?
We know people that do it all the time and get away with it. You know, it just depends. You know, I don't recommend it. If the sleeve is available, use it. It's insurance to make sure that that seal that you're putting on that stem is not going to get damaged. So I would not recommend not using it. But again, a lot of guys out there that do it every day, and it works just fine. You know, you just never know when it's going to pop up and bite you. So.
Okay. No, super. For those of you that we still have questions to get, Brian will get back to you. Like I say, we've got everybody's email addresses, and any of those questions or anybody that's looking for charts or any of the information, Brian will forward those along to you once he gets through them there tomorrow. So Brian, thank you very much. We do appreciate your time and putting the presentation together. Mm-hmm. And what we'll do now is bring Amanda back on, and she's just going to go through with you the last part of the presentation about the survey and about contact.
Yeah. And again, apologize for the technical glitch here with the full screen situation. So.
No worries. All right. Thank you, everybody, again for your time today. We appreciate it. We know how valuable your time is, and we appreciate you taking a little time out of your day to watch our webinar. You will get a follow-up email tomorrow with a link to the recording of today's webinar for you to review, share as you would like. It's yours to use as you would, however you would like. Also, when you leave the webinar today, there will be a short survey. Please take a moment and fill that out. Let us know how we are doing. If you had any additional questions that didn't get answered, any of that kind of stuff, and we will be going through and evaluating that. And the last bit of information is just our contact info. You can reach any of us here at AERA by calling 815-526-7600, or you're welcome to email us. Also, if you just reply to any of these emails from Constant Contact, it'll come straight to me. And if you have a question for Brian or Rob or whomever, I will pass it along to them. So that's a quick and easy way for you guys to reach out to us as well. So thanks again, everybody, and have a great rest of your day.